22. What are the equations of the horizontal asymptotes of the graph? Okay, this was a long time ago. So horizontal asymptotes are lines that the graph approaches as x approaches infinity or negative infinity. So what that means is you have to take the limit of this function as x approaches positive infinity. So remember, you're just looking at the leading terms, and in the numerator that's 2x. In the denominator, though, it's square root of x squared, which is absolute x. But absolute x is the same as x here because x approaches infinity. So x is a positive number. So x and 2x are the same thing. This limit is 2. Y equal to 2 is one of the horizontal asymptotes, so it's not that or this. So if that's all you could do, then you have to choose between C and D. Now you have to also see what's happening if x goes to negative infinity. And if I look at this, if x is going to negative infinity, these are not the same. This will be positive because the absolute value, but this is going to negative infinity. So the numbers are going to be the same, but this is going to be negative, this is going to be positive of the same number. So negative a million over a million, negative a billion over a billion, right? So these are going to give you negative 1, so this is negative 2. So these are the two lines that are the horizontal asymptotes of the graph. Okay. Ooh, we just had this today on the quiz. So this is the second fundamental theorem. So you just substitute the limit, so it's x squared, that limit, times the chain rule part, which is 2x. And x is positive, so square root of x squared is x, so the whole thing is 2x squared. Could that have been that easy? That's it. Let's choice D. Okay, 24. Differential equation. Okay, separate the variables. And substitute this after you integrate 1, 4. Okay, so we're going to substitute. So we have dy over y equals negative 2x dx. Gosh, I can't do this by looking at my phone. Okay, so antiderivative ln y equals negative x squared plus c. Okay, so we plug in 1, 4. So c equals ln of 4 plus 1. And now we plug it back into here because we need the y equals. So we get y. If I take e to both sides, like e like this, right, to get rid of the ln, to cancel it out, we get y is equal to e to the negative x squared plus c, which is ln of 4 plus 1. Okay. So remember that e to the ln of something you can cancel out. You can simplify rather. So this is e to the ln of 4. I could do that. Times e to the negative x squared plus 1. Because you add the powers if the bases are the same. I'm doing this backwards, right? Because I know I can simplify this. This is just 4. So that should be my answer. Let's see, 4e to the negative x squared plus 1. That would be choice D. Okay. Oh, well, this is lovely. You could use L'Hopital's if you'd like, but if you notice that this is the definition of the derivative, it's f of x plus h minus f of x over h. F of x here is sine x at x equal to pi over 3. So you're finding the derivative of this function at that x value. So that would be cosine of pi over 3, which is a half, and that would be choice B. That's it. don't think that... Does L'Hopital even work here? So you don't quite get 0, 0. Cosine of pi over 3 plus h. Yeah, that would work. Because you just get cosine of pi over 3, which is 1/2. Okay, 26. Ooh, decreasing. Okay, so when is a function decreasing? When its derivative is negative. Okie doke. So let's find the derivative, yeah? So second fundamental theorem, simpler here with no chain rule. X cubed minus x squared minus 6x. And for convenience, they made the denominator positive. So we can completely ignore that. So the sign of this will depend on the numerator. And we want to see when this is negative, right? So we have to first see where it's 0. This is x cubed. So let's factor that a bit. So we have x squared minus x minus 6. Oops. So we have x minus 3x plus 2. So 0, 3, and negative 2. Okay, so now we just have to do the sign analysis chart. Okay, so G prime, if you plug in negative 3 into here, so let's plug in negative 3 into here, right? Because it's easier to see the sign. So if I plug in negative 3, I'm going to get negative, 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 that's negative. If I plug in negative 1, I'm going to get negative, negative, positive. If I plug in a 1, I get positive, negative, positive, which is negative. Plug in 4, positive, positive, positive. But I'm looking for g of x decreasing, so I'm looking at this interval and that interval, less than negative 2 and between 0 and 3. Looks like A. They're including the 2 and the 3 and the 0, and I'm not entirely sure why. I wouldn't, because at those x values, the derivative is clearly 0. Moving along. 27 and 28. Ugh. Okay. Excuse me. There was a formula for this, but I didn't really enforce it. Excuse me. Because there's no need to remember the formula. Oh, sorry, let me just put this. Okay, so I found that it's easier, maybe even faster a little bit, if you just remember the basic concept of inverse. Inverse means you switch the x and the y, right? So we have x equals sine y plus 2y plus 1. That's my inverse, okay? And I'm looking for its derivative when x is 1, right? They're not giving me the y of it, so I'll have to find the y myself. So let's find the y now. So if I know that x is 1 and I plug it in, I would get 1 equals sine y plus 2y plus 1. 1's cancels out. Sine y plus 2y. By trial and error, you see the only way this would be 0 if this were, is if y were 0. Okay, so when x is 1, y is 0. This is a point on my inverse. Okay, so now I want to find the derivative of this. So 1 equals sine of y. The derivative of that is cosine y, y prime, plus 2y prime. Okay, so I'm plugging in my y is 0. So 1 equals cos 0, y prime, plus 2y prime. This is 1. So 1y prime plus 2y prime is 3y prime. Y prime is 1/3. And there's that. Okay. If you want to use the formula, I guess we can try it. Let's see. So the formula for the inverse, if you're trying to find a it's 1 over f prime f inverse of x. So the derivative at x equal to 1 would be f prime f inverse of 1 okay, and we found that to be 0, right? Send to 0. F inverse of x. I feel like I'm missing something. F inverse of x is 0. Right. Okay. So then f prime of 0, well, we go back here. What's f prime? Let's find it. F prime equals cos x plus 2, right? So at 0, that would be 3. I don't know. My students always find this a little confusing, so do as you wish. So the choice here is a third, which is choice A. And I have these here. 27 is choice A. Okay. Did we actually finish? Almost finished. Oof. They always put this to last question. Yikes. Okay. Let's see. Let f be the function, blah, blah, blah. Let p sub 3 be the third degree Taylor polynomial. Okay. Okay. So I want to find the error, the smallest possible error in this case, when the third degree polynomial of Taylor's is used to approximate some function f. Okay, well, so then I have to know what the error is, right? So the error is going to be less than f of, I don't know if I want to give you the formula, n plus 1, I guess, over n plus 1 factorial x to the n plus 1, right? That's it. And it's at some number z. Okay, and in this particular problem, this is the error. You want that to be the smallest possible error. So they're telling us that the derivative is less than that. So this is going to be less than n plus 1 over n plus 2 if you follow this formula. Right, because instead of n, we have n plus 1. So we replace all n's with n plus 1. So they become this, and they're independent of z. X is 1, so we plug that in. Let's see, over n plus 1 factorial. Okay, we don't need the absolute value because these are all positive. And again, 1 to something is just 1. Okay, now n, they say, is between 1 and 4. So in order to have this the smallest possible number, what, I think 4, if we put in 4, let's see, if n is 4, to 2 degree, n is between 1 and 4. Oh, so n is between 1 and 4 here. So that means, yeah, I don't have to use n plus 1 because whatever, if I have the first derivative or the second or the third or the fourth, and in this case I have the fourth because I'm using the third degree Taylor polynomial, so this would be f of n plus 1, which would be the fourth derivative, but this applies for the fourth derivative as well, so I didn't have to use n plus 1 and n plus 2. I could just leave it. So we could try both extremes. If n is 1, let's see what we get. That number would become 1 over 2 times 2 factorial, right, which is a quarter. If n is 4, That would be 4 over 5 times 5 factorial. Is that any choice? Number 28. Okay. So 4 over 5. Their choice is B, so I'm missing something. Did I forget to divide? No, I did divide by that. Over n plus 1 factorial. Well, that's the closest one to the answer, I guess. Gotta figure why it's 4 factorial, so they must have left this as n factorial. To the n. So if we left it as f to the n, x to the n over n factorial. Then it would be n over n plus 1 times n factorial times 1 to the n. And then at n equal to 4, it would be 4 over 5 times 4 factorial, which would be this. I guess that's what they did. This is an approximation, so you can play around with it, which is what makes it difficult for people. This would also be a good approximation for the error. It would probably be better because it's smaller, but I guess they use the nth term. So that was that nasty last problem.